Hi, this is Hob Webinar with Universal Robotics. Welcome to my office. I would like to just have a little whiteboard sketch discussion for engineers around robotic depalletizing, throughput versus flexibility. What I like to do on this graph behind you is map the application space and the technologies that fit within that application space. So to do that, what I put on the bottom here is flexibility. It's the number of unique SKUs that you want to depalletize. It's a logarithmic scale. You can see it's 10, 100, 1,000, 10,000, or 100,000 different SKUs. The differences might be their dimensions, the type of material in the case, carton, or box. Might be whether it's beige or white cardboard, might be wood. Might be the color. It might be have graphics or no graphics, labeling, unique labeling, not whatever those things. But mainly it's around the dimensions and the type of materials. That's the flexibility. Up the vertical axis, it's a linear scale. In this case, it's overall throughput in terms of the number of cartons or cases you want to move per hour. This is on an ongoing basis. So some of the options available to you today, obviously there is manual labor by a human, and typically they're the most flexible thing out there, but they can't lift normally more than 50 pounds, maybe a little more than that, but any number of SKUs they can recognize, pick them up, and move them. They normally don't exceed 500 an hour on average over time. So that's the manual option. Let's talk about robots. So in terms of robots, typically the first category that comes to mind is vision-guided robots. Call that VGR. If you do a single pick down here, it's normally 500 to 900 cases per hour that a vision-guided robot could move, depending on the physics and the geometry of the situation and the weight of the boxes and so forth. If you're doing a double pick, I'll put a 2 in here for double pick, moving 2 boxes, it's not necessarily twice the 900 or 1800 unless all of the SKUs are totally flat. They're always the same way. You can plan on always getting double picks. But if it's a random pallet stack, which is part of what comes with greater flexibility, you may have to pick some on end and then go from there. So normally it's about 1.5 times what you'd get with a single throughput. So that's vision-guided robotics. Advanced vision-guided robotics allows a little more flexibility, and the advanced part is referring to the vision. So this is a VGR. Again, you'd have double or single. The same concept, but the flexibility increases. But what you're beginning to bump into here is that the vision cannot ascertain quickly random objects at this sort of throughput rate. That's one issue. The second issue is the overall memory within the smart camera or smart device might only handle 10 or 20 objects. If you're doing object recognition, shape matching, surface matching to a known that you have in resident memory, there's a limit to how much you can put in that. If you're leveraging or using the computer on the robot, it's doing other activities and it also only has a certain amount of memory. And so there's a limit to what those can do. For Universal Robotics, our advanced vision guided software package is called Spatial Vision Robotics. Now let's take a look on out here. There's a new category called machine learning guided robot. And in our case, that's our flagship product called Neocortex, our patented software, machine learning. It sits on top of and supervises the overall 3D and 2D and 2.5D analysis, and it handles unlimited number of SKUs. And so we have, and again, the same rule applies in terms of the robot, whether it's a double pick or single pick. You get the same kind of throughput, but now you get unlimited SKUs. So we're actually doing installations for customers out in this kind of space right now. So that's machine learning guided robots. Above this, what you have is you'll have like a pallet machine or depalletizing machine. And they typically begin doing it by layer. If it's fixed, if it's only like a few products fixed, they might do an entire layer. You might have a robot that's doing an entire layer with a very few number of parts. So if you can do that, that's great. The price points from here up typically start at $250,000. Below this, you can typically get a workstation for around $250,000, give or take. Hopefully this will help you as you make decisions on throughput versus flexibility. This is Hob with Universal Robotics.